Okay, now let's understand some principles of muscle contractions and muscles actions and interactions. First of all, remember, muscles pull, they can never push. So, in order for a muscle to reverse its movement, we need another muscle to do that because they can I can pull my forearm towards my elbow, which is flexion at the elbow, right? But I cannot push it back. So I need another muscle to pull back my forearm into an anatomical position. Okay? So just in that, for every movement, we need a pair of muscle. One, the one that produces the movement, and the other one that antagonizes or oppose the movement. And both of these muscles are located on opposite sides of the joint. Another important, very important factor to remember in here, in order for a muscle to produce movement at any joint, it has to cross a joint. If it doesn't cross a joint, it won't produce, by the principles of leverage, it won't produce any movement. Another thing, given these brief descriptions, we know that the main muscle that creates or produces a certain specific movement, that's the prime mover. Okay, the prime mover or agonist is the one in charge to produce, for example, in here, to flex the arm. And we need an antagonist to reverse that movement. But to this prime mover, we can add helpers. And the helpers are called synergists. Are muscles, it can be one muscle or several muscles that are going to help that the prime mover to produce the movement. For example, it can act by adding extra force. The brachialis can lift the ulna, brachio, and the biceps brachia can lift the radius. So in both, biceps brachia is synergist of the prime mover of flexion, which is the brachialis. Those muscles, don't worry, we will cover those on the lab. But see that they act together to perform a single movement. That's one way to act. Another way is to reduce undesirable movements by that muscle. Their muscles, usually they're big muscles, for example, the deltoid, that has several actions. It can flex the arm, it can extend, the posterior fibers can extend the arm, the lateral fibers can abduct the arm. So synergist can, if we're looking forward to flex the arm, for example, another synergist can cancel the superior and the posterior fibers, so just the anterior fibers, the flexor fibers, are active on that particular moment. So that's the ways a synergist act. Another type of synergists are fixators. These are muscles that are not that much involved in the movement, but they stabilize the joint when the other muscles are producing the movement or causing the movement. And the antagonist is the muscle that reverses or opposes the movement. So when a prime mover and an antagonist are working, one is contracting, the antagonist has to be either relaxed or stretched. I put this, I hope it helps to understand a little bit this. Put my rubber band here around the distal end of the humerus. And here I have the ulna. No, this is the radius, I'm seeing the screen. The radius and the ulna. And I have one muscle, let's put it, I don't know, in the ulna anteriorly and the other one posteriorly. Let me grab it like that. Okay? And I have here the elbow joint. Okay, so understand that one muscle, see that they need to cross the joint, right? The muscle that is crossing the joint anteriorly is during the flexion of the forearm at the elbow is going to contract. That means that it's going to shorten. See, it shortens, it gets smaller, so it can lift, it can lift the, can you see that? No, right? Okay, can you see that, how it bulks? So it needs to shorten in order to lift the ulna. But at the same time, that that muscle is shortening, we need to stretch the posterior muscle. Let's say that that's the triceps, one of the heads of the triceps. So at the same moment the prime mover is contracting, this one is stretching. But after, to reverse this movement, remember, we cannot push, a muscle cannot push the bone. So now I need to contract the triceps brachii, or the posterior muscle in there, and the anterior muscle needs to relax. So during this movement, now the one that was antagonist during forearm flexion now is acting as prime mover during forearm extension. And the one that was acting as a prime mover during forearm flexion is acting now as an antagonist. Antagonist contract usually eccentrically to allow the movement, to reverse the movement, working against gravity, to give it some, to make it smooth, slowing movement, not jerking movement. Okay. The other thing that I wanted to talk about in this movement is, in this video, I'm saturated with movements, is how can, and this is so important, and I want you to apply this slide in every muscle that you study from now to the rest of the term. This is going to ease so much the studying and understanding of muscles, and it's going to decrease the amount of material that you need to memorize. Now, a muscle, we said that it will cross a joint, right? If that muscle is crossing the joint anteriorly, okay, this is the front. If it crosses the joint anteriorly, when it contracts, when we shorten that muscle, we're going to produce flexion. Flexion, in this case, of the forearm. But let's go to the wrist. If we put the muscle here in the anterior aspect, to the anterior aspect of the wrist, when we shorten, we're going to flex the wrist as well, right? Same thing with the arm. If I place a muscle in any part of the scapula or the clavicle to the humerus, okay, when I shorten this muscle, I'm going to flex the arm at the shoulder. That's if I place it anteriorly, like in here. See, I'm going to produce flexion. The example they're using in there is the pectoralis major. Now let's put it back. They're using now the latissimus dorsi, crossing the joint posteriorly. If it's posteriorly, when I shorten that muscle, I can extend or hyperextend the arm at the shoulder. If I place now my piece of muscle, this is the olecranon process, see? If I now place it behind, posterior to the joint, when the joint is flexed and I contract that muscle, I can extend it, can put it back. Same thing with the wrist. And the same thing with a little bit, some differences that we talk about later, but the same thing applies in most of the joints in the lower limbs. See, posterior aspect of the hand, when the hand is flexed and I contract that muscle, posterior muscle, I can extend or hyperextend the wrist. Now, what happens if I place the muscle laterally? if it crosses the joints superiorly and laterally. When I pull it, imagine that I have a string from here, from any part of your scapula or clavicle to the lateral aspect of the humerus. When I pull, let's pull the string. What are you doing? You're lifting the arm, and this movement is called abduction, right? Same thing in your wrist. This is the lateral side, this is my thumb. Let's place a string from here, which is our muscle, from this lateral side of the radius to this side in your thumb. So when I place like this, I place the string and I pull it, okay, I'm gonna pull the string, I can abduct the hand. Now let's put it medially in this side. When I pull this string from here to here, I'm going to adduct. Okay, so muscles located on the lateral side of the joint will abduct, abduction, and if I have a string now from the medial aspect of your humerus to any part of the ribs or scapula, and I pull it, I'm going to adduct or reverse the movement. So as you can see, most of the muscles that we're going to study, they come in groups. We have an agonist and antagonist. We have a flexor and we have an extensor. The same muscle cannot produce, most of the time, cannot produce the same movement. We need another muscle. Or if the muscle is big, we need another group of fibers of the same muscle to reverse the movement. The same muscle or the muscle that abduct the arm cannot adduct it back in place. Okay, we need a different muscle to adduct the arm. Okay, I hope this was clear. See you in the next video.